Hello everyone, and welcome back. In this lecture, we'll show you how to use the GroupBy method and how to sort your data. Before we get started, I'd just like to introduce what grouping is and what it does. Grouping essentially allows us to aggregate or group rows together based off of a column and then perform a function on them. In this example, we've got a table containing 3 different IDs of 1, 2, and 3, and then each of these rows have got an associated value. If we group these rows by the ID column and then aggregate them by summing them, for example, we'll see that we get our output containing the summed values for each unique ID. So for our ID of 1 here, we initially had 2 values of 10 and 20, but when grouped and summed, this comes to a result of 30. And then of course the same is true for our other IDs. There are other aggregate functions available, such as mean, median, min, max, and others, but essentially all an aggregate function does is perform a calculation on a set of values and returns a single aggregated result. Let's move over into Jupyter Notebook and get started. Okay, File. So here we are inside of our notebook. For this lecture, I've already gone ahead and imported NumPy and Pandas, as well as copied in this dictionary here. You can find this dictionary in the grouping and sorting notebook, which you can see here. Just to quickly explain what this dataset is, it contains some information on various students along with their grades for English, Maths, and Science. I used NumPy to generate all of these as random values. And there's a new function here that we didn't look at, which is np.clip. So let's briefly go through and explain what all this code does. The np.clip function is used to make sure that all of the numbers fall within the range of 1 and 100. And we can see these 2 arguments over here off to the right. np.random.normal will create an array of numbers with a normal distribution, and it's got a mean of 70 because of the loc or LOC argument, and then a standard deviation of 15, which is the scale here. And then this is an array of 1000 numbers because of the size. And finally, we just cast all of our numbers, this column, to an integer. We'll go ahead and cast this to a data frame so that we can then take a proper look at its values. For this lecture, the important columns will either be the teacher name or class ID. These contain random numbers between 1 and 6, as we can see from our dictionary code. We could group our data on either of these columns, but I'll use the teacher name column. We can go ahead and say df.groupby, and then inside of our parentheses, we'll just pass in the name of the column that we want to group by, which, as mentioned, in this case, I'll use our teacher name. And then if we run this, it'll output a Pandas GroupBy object. So let's go ahead and assign this object to a variable, which I'll call teachers grouped. After we grouped our data, the next step will be to perform some kind of aggregate function on it, like we mentioned before. For this example, let's calculate the mean so that we can see the average score for all of our students taught by a particular teacher. We can go ahead and type in the name of our variable and then call mean on this. When we run this though, we'll see that we get an error telling us that the aggregate function failed. And off to the right, we can see that this is the object, the type. Basically, what this is telling us is that we are trying to calculate the mean for a non-numeric column. If we call the dtypes method on our data frame, we'll see that we have 2 columns with an object data type, which are the student name and the teacher name columns. To get around this issue, we could either drop the name column or only group by specific columns. We've already covered how to drop columns, so I'll show you how we can group but only by specified columns. We wanted to have a look at each teacher's student's average score for each subject. what we'll do is create a new variable called teachers grouped 2, and then we'll say df.groupby, and we'll group by our teacher name column again. But then after this, we can provide a list of the columns that we want to group. So I'll put in English, Maths, and Science. So then only these columns will be included in the group. And then if we call mean on our new grouped variable, then it'll return the average score for our students for each subject, but grouped by the teacher name. Due to the way in which we generated our random numbers, with each value for each subject getting the same mean, as you can see here, there's not going to be too much variation between the average score for each of our different teachers. Let's have a look at a few other helpful aggregation functions. Starting with count, this will just return how many values fell into that particular group. So if we call that on our grouped data here, we'll see how many students each teacher had for each of the 3 subjects. Next, we have max and min, which will return the largest and smallest values for each group respectively. And finally, we'll have a look at describe. And this just returns summary statistics for each group within our data frame, as we can see here. So describe is a very good way of getting an overview of the grouped data in our data frame. As this stretches across the screen quite a lot, we could actually call the transpose method on this, and that will make it a little easier to read, but it depends on which version you prefer. Also, if we wanted to view this information but only for a single column or group, we could pass an index in at the end, and then this will just return data for a single column, which is a little easier to look at. Okay, and now that we've looked at how to group our data in Pandas, let's have a look at how to sort it too. If we wanted to sort our data frame and students by their maths score, we could say df and then call sort values method. If we have a look at the documentation for this, we can see its available parameters. The first one is the by parameter, and this is the column that we want to sort our data by. So I'll go ahead and pass that in here, and I'll just say that this is our maths column. If we run this, it'll return our data frame, but then sorted by the maths column. And by default, this method sorts in ascending order, but if we wanted to sort this in descending order, we could pass in our ascending argument and set it to be false. Like when we looked at sorting data in Excel, we're also able to sort our data in Pandas by multiple different levels or columns as well. For our by argument, instead of just passing in a single value, we could actually pass in a list of columns. So I'll put in maths, which will be our first level of sort, and then English will be our secondary level. And then if we run this, we can see that we've sorted by our maths column first, which we set as our first level, and then by our English scores. And again, by default, this is sorted in ascending order. It's also possible to sort by object or string data types too. So if we sort by our teacher name column, which we know is an object data type, this will then sort the column in alphabetical order. And finally, like a lot of the other methods we've looked at, these changes won't apply to our actual data frame unless we specifically pass in the in-place argument and set it to true. Or again, we could just reassign the result of this back to our df variable. Okay, so that's everything you'll need to know about how to group and sort our data inside of Pandas. We'll leave this one here for now, and then in the next lecture, we'll have a look at how to deal with missing rows or values inside of Pandas too. Thanks everyone, and I'll see you in the next lecture.